Hello Lightning Leaders and welcome to another math video. Today we're going to be talking about the metric unit. This is something that we did way back in Module 2, and if I remember correctly there was somewhere around October, November that we did this stuff, so it's been a while. Now I know I've been calling this review, but this is stuff we were going to do anyways, because we were going to be preparing for the New York State test, which isn't happening this year anymore, but this is something that we would have been doing anyways, so it's kind of a mix in between review and continuing on with what our plan was at school. Now, this is actually take 2 of this video. I've just finished recording the first round, and of course, as you guys know, the iPad hates me, and it ran out of storage and didn't get the whole video, and then the sun was glaring on the screen and you couldn't see half of it anyways. So we're going to try this again. It wouldn't be math without Mr. S making a mistake and the iPad giving me issues, but you know, it is what it is. So, let's try this again. Metric unit. Now, we don't use the metric system here in the United States. We're one of the very few countries in the world that doesn't use it. I guess we're just special that way. But if you have ever been to Canada, you have been exposed to the metric unit because their cars are in kilometers per hour, their roads are measured in kilometers, their drinks are measured in liters, their bodies are weighed in grams, their bodies are measured in meters as well. So why do we learn this? Well, it's important to learn anyways, especially if you want to become a mathematician or a scientist when you grow up, because the world of science uses the metric system. And it's important to know the metric system. I, for one, think the metric system is easier to use than our system, but that's just my opinion. Because it all revolves around multiplying and dividing by 10, which, as we all know, is pretty nice to do. Now, there's 4 conversions we have to talk about. And I'm going to write them all out on the board here. 3 of the 4 are going to look almost identical, because they really are. It's just the only difference is their units. Now, the first one is 1 liter equals 1,000 milliliters. If we were to measure our drinks, we could use liters in milliliters. Now, if you were to go to the store and get a bottle of soda, you're probably getting a 2-liter bottle of soda. It's a lot of soda. But if I were to try to measure how much iced tea is left in my glass, I can't use a liter to figure that out. There's no way there's a liter in this glass. So what I would use is milliliters, because it's a smaller unit. There's probably, I don't know, if I had to guess, maybe 100 milliliters in here? I don't know. I'm just making a random guess. I really don't know. Now, another unit we could use is meters. 1 kilometer is equal to 1,000 meters. So now we have a second conversion here, and if you look, 1 equals 1,000. 1 kilometer is equal to 1,000 meters. Now, if you were to become a track and field star, maybe in middle school, high school, and beyond, and you were to start running events on the track, they would be measured in meters. 200 meter, 400 meter, 800 meter, right? They measure them in meters. And if you play Pokemon Go on your phone, it also measures the times to hatch those eggs in meters as well. There's the 2 kilometer, the 5 kilometer, and the 10 kilometer egg. So this is how you can figure out how long you have to walk for that. Now, there's one more unit, and this one has to deal with weight. 1 kilogram is equal to 1,000 grams. Now, if you remember our lesson on this in the classroom, I passed around those colorful discs that had different weights, and the 1 gram one, I think it was purple. It was super, super light. And then the 1,000 gram one was the kilogram, which was the blue one. It was that big brick that was super heavy, right? This is how we could measure the weight of something using the metric system. Now, there's also one more conversion that we talked about. And this one we see on our meter sticks and we see on our rulers. And this one was 1 meter equals 100 centimeters. Centimeters are an even smaller unit of measurement than a meter. Just like an inch is smaller than a foot, which is smaller than a mile. That's kind of the parallel comparison, but they're no way, shape, or form the same thing. What we're going to do next is we're going to keep these conversions in mind, and we're going to go back and forth between big units and small units, and then practice adding a couple numbers together. These are the things we need to keep in mind. The big thing to think about is one big thing equals 1,000 small things. Notice how we have an uppercase letter here, we have an uppercase letter here, we have an uppercase letter here, and these ones all have lowercase. Milli, meter, gram, liter, kilometer, kilogram. Now, if we had more time in the classroom, even before we entered this thing, we would have talked a lot more about Greek and Latin roots, and we would have learned a lot about milli and kilo as part of that study, because they are prefixes. See how ELA ties into math? I can hear your groans through the camera. Okay, let's do some conversions here. So let me erase this. And if you see me staring off into the distance, it's because I'm staring off at the computer over there with the example problems on it. So let's see here. Let's start with 9 kilometers, and I want to know how many meters that is. So I have to think to myself, what was that conversion we talked about? 1 kilometer equals 1,000 meters. So what we have to do here is really we have to think, okay, one of these equals 1,000 of these, but I have 9 of them. So we have to do some multiplication. I have 9 of these. 9 times 1,000 is each of them, and that will get me my answer. So 9 kilograms is actually 9,000 meters. And that's how we would do that conversion. Now, we're going to do another one using grams that's a little trickier. Ooh, this time we've got some mixed units here, kilograms and grams. They're not the same. Just like with our fractions, when the bottom numbers weren't the same, we can't put them together until they're the same. But I can turn these kilograms into grams using our conversion. 1 kilogram equals 1,000 grams. So now I just have to add these 74 grams into here, because now we have the same unit. And there's my answer. Let's try one more with liters. Let's try this one. 2 liters, 20 milliliters. Well, again, just like we did up here, I know that 1,000 milliliters is in a liter, but I have 2 of them. So 2 times 1,000 gives me 2,000, and then I add in my 20. And now I know that 2,020 milliliters is the same as 2 liters, 20 milliliters. Now, I'm going to erase this, and we're going to try to add some of these together here. Let's do an addition question here. Ooh. 100 liters, 99 milliliters plus 2,999 milliliters. Oh boy. I don't have the same units here. I can't just add these together. Yeah, I have milliliters here and milliliters here, but I have liters here. I need to turn this into milliliters so that I can add all this together. Let's think. 1 liter equals 1,000 milliliters. So I have to do 100 times 1,000. Now, you might be thinking, whoa, I can't do this. We're only in 4th grade. But I've taught you what you can do. 1 times 1 is 1. Now how many zeros are there? 1, 2, 3, 4, 5. It's 100,000. We started in the thousands place, and then we went over 2 place values. We jumped to the left 2 more place values, adding in a couple more zeros on our answer. So now I know I have 100,099. Mr. S, where's that 99 coming from? Great question. This whole thing is one number. We took this 100,000 or 100 liters and turned it into milliliters, but this piece was still here, so we had to bring it back in. Now we can add in our 2,999 milliliters to get our answer. Let's see here. 9 and 9 is 8, carry the 1. 19, carry the 1. 10, carry the 1. 3. So now we know that our answer is 103,098 milliliters. All right, what I'm going to do now is I'm going to put a cut in the video, and when you come back, which will just be a split second for you, there'll be some example questions up on the board here, kind of like an exit ticket. And what I want you to do is try to figure them out. Now, what I'm doing over these next couple weeks is I'm going to be posting 3 ELA videos and 3 math videos a week, so a total of 6 over the next 2 weeks. Each week, I want you to pick 1 ELA video and 1 math video that you send me your answers to. Now, I want you to do the work for all 3 videos, all the videos every week, but I'm only asking you to send me the work for 1 of each subject. I think that's a fair deal. That way, you're still practicing the stuff, but you don't have to hog your device all the time if you're sharing it with your family members. So I'm going to put a cut here, put some example questions on the board. You're going to try to figure them out, and if this is the video you choose to send me your answers to, I can't wait to see your work. All right, be right back. All right, Lightning Leaders, welcome back. So I kind of just quickly put together what would be an exit ticket for this lesson. And what I want you to do is figure out the missing numbers here on these blanks, and then try to figure out this addition sentence here. Remember to keep in mind, you've got kilometers and meters, so be very careful with your addition. I would recommend taking this from the horizontal view here and turning it into the vertical view. The standard algorithm, it might be a little easier for you to see this. Give it a shot, and if this is the video you choose to show your work in, I look forward to receiving your work. See you guys next time when we talk about geometry. See you then.